Part 3 and final part of our spectrophotometry lab. So with the first part, we created that absorption spectrum. What colors of the visible light spectrum do we see at each particular wavelength that you guys created there? The second part, we worked with 5 milliliters of water as well as 5 milliliters of copper sulfate. And we went through and we found the maximum absorption. At what wavelength do we have the most absorption of that visible light, of that copper sulfate? It should have been determined, hopefully everybody in class has the same data, but it should have been determined that at the wavelength of 620 was my maximum absorption. And that's important because for part 3 that we're doing here, we're going to create what is known as a dilution series with water and copper sulfate. And we're going to utilize that maximum absorption of 620, which means that my spectrophotometer will be set for that particular wavelength for the entire part of it. So in front of me, I see a whole bunch of tubes, and this is to create our dilution series. So within your lab, you have a page that looks like this. So I have 11 tubes that are set up in front of me. They're all the same size. It's one of my constants. And within those tubes, it tells me what I should put into them. So all my tubes are going to have a total of 5 milliliters in them. And I'm creating different concentrations of copper sulfate. So in terms of molarity, my first tube, which is 5 mLs of water and 0 copper sulfate, I have a 0 molarity. But then I'm going to increase. I'm going to go to 4.5 milliliters of water and a half ml of copper sulfate, 4 mLs of water, 1 ml of copper sulfate. So water is going to decrease, copper sulfate is going to increase. I still end up with 5 mLs in every one of my tubes. It's also a constant. So my 11th tube has 5 mLs of copper sulfate and 0 of water. So what's happening is I'm increasing my molarity of copper sulfate as I go through, and I want to see what's my absorption and transmittance of these particular tubes, and we're going to make some graphs out of this. So I'm going to go through and talk to you guys a little bit about the pie pumps that you see in front of you. So last week we did micropipetting, where we looked at teeny tiny little amounts. These particular pumps that you guys see in front of you here are known as pie pumps. And these pie pumps are kind of like graduated cylinders, meaning they can measure up to 10 mLs. So if we're starting at the bottom here, it actually will count backwards for you, because as you're filling them up, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 mLs. And you can also do your half mLs on here as well. This one's a little bit different. Instead of just pouring into a graduated cylinder, I would actually use a little dial here. And as I pull down this dial, you're going to notice the top comes up. It's actually going to absorb liquid up to the point where we need it. So it's very easy to measure. If you go too high, you release a little bit. It also has a quick release. So if I hit this button here, it's going to kind of slowly release the material out. You can release the material out just by pushing that button down as well. So I have a couple things with my pie pumps. I don't want to cross-contaminate them, just like tips within our micropipetting. So I have a flask of copper sulfate. I have a flask of just plain water. So I don't want to cross-contaminate those pie pumps. So you're going to notice within my copper sulfate, I have a 10 ml one. It's got a little blue tape on it, so I know it's the one that belongs in the blue solution. I also have a 1 ml tube in there as well, and it does the same thing. So I can measure up to 1 ml, and this is what I'm going to be using to measure those tiny half milliliters that I need. So once again, as you're going through and I want to actually measure something, I'm just going to go through and I'm going to wheel this up. And as I wheel that up, what you're going to see is that this is going to fill up. I can slowly push that wheel down and it's going to release my liquid. And I can measure to the point that I want to measure. So if you're following through that particular chart, your first tube, it's going to have, I'm trying to get a good shot here for you guys. Your first tube is going to have 5 mLs of water. So if I'm looking at 5 mLs of water, I'm going to push copper sulfate back just a little bit. I'm going to use my 10 ml pie pump. I'm going to go through, and this is much easier if you're sitting down and having it eye level. But I'm going to go to my 5 mark on this, and I want to keep them all identical. That should also be a constant. So as I go through, I'm measuring my 5, can't find my 5 ml mark on that. I'm going to put it into my first tube, and I'm going to slowly release all the way down, and I'm putting those 5 mLs into that particular tube. Next tube, next to it, tube number 2, it should be 4.5 milliliters of water. So I'm going to go up to my 4.5 mark on here, I don't need to utilize the half. I can actually go to 4.5. So this looks a little bit different because it looks like I'm at 6.5, but it's not. If you're counting from the bottom, I'm counting upwards or counting backwards. That's going to give me my 4.5. So the second tube, I'm going to put 4.5 in, but I also need a 0.5 milliliter of copper sulfate. So that's where I'm going to go back to my blue. I'm going to utilize my smaller micro pipe or pie pump, my 0.5 ml one. So remember, this is the one that measures 1 ml total. I'm going to go all the way up and come back down to my half point. That's going to go into tube 2. So within the classroom, they're going to be working with partners, and I usually suggest one partner do the water, one partner do the copper sulfate. You're going all the way through. Next, I need 4 mLs of water. If you're following your chart, we're going to go 4 mLs of water and 1 ml of copper sulfate. And you can use either one. You can use your 1 ml one, or you can use your 10 ml one. But we're just going to measure our 1 milliliter of copper sulfate. That's going to go into tube 3. So far I have 3 tubes. They should all have 5 milliliters within them. That is also a constant. You're going to notice the tubes start out clear, 5 mLs of water, pretty dilute, 4.5 mLs of water, a 0.5 ml of copper sulfate. I have 4 and 1 of water and copper sulfate. You're going to keep going until that very last tube has just 5 mLs of copper sulfate in it. I'm going to kind of do what the little cooking shows do, where they kind of take one recipe away and go, oh look, here they are completed. So what you should notice is, and this is one of the biggest things I don't see within the classroom, is all my tubes should be equal all the way through, meaning they're all the same amount. Here it looks a little different because of my angle of my camera, but they are all the same amount. The next thing I should notice, it's also a little hard to see, I'm going to see if I can pop some white behind this, is that you should have an increasing color of them, because remember, they're getting stronger in terms of their molarity. They have more and more copper sulfate as you go all the way to tube number 11, which you do see. So this is what I'm utilizing for part 3 once they have those 11 tubes created. So part 3 is pretty quick, pretty easy. I'm just going to be swapping out tubes. So what am I doing? So I'm going back to my spectrophotometer. Remember, for part 2, I said we are going to go through and set that spectrophotometer what my maximum absorption was for part 2, and that was 620 for that particular copper sulfate. So I'm setting this to 620. My toggle switch is set to absorption, and I'm going to start out with water, because that's what tube number 1 actually is. So I start out with some water, I pop it in, I'm going to re-zero it. So at absorption, I want to re-zero this now.